Okay, this is an introduction to cutting the seats in a cylinder head, and this is on a diesel application. So first we've got to take a look at some of the tools and then understand the angles that we're looking for so that we can correct the position of the valve to the valve seat in the head, and then again falling within guidelines for the stem installed height and the seat width that we're looking for. The contact width is very important to actually dissipate the heat from the valve face up through the stem and then out to the guide. Now, part of the guide's responsibility is taking up about 25% of the heat loading. The important angle is the valve face to valve seat. That particular point of contact actually can absorb and dissipate 75% of the heat loading on the valve. And the valve itself has a very thick poppet portion of the head, and we subject a lot of heat to it. So we need to allow the heat to go into it and then to come out through the valve seat to face and then out through the cooling system in the head. The rest of the heat travels up and again loses about 25% of the heat loading out to the guide in the cylinder head. Okay, so taking a look at some of the tools, one is a pilot that goes into the guide of the cylinder head, and then we have a pilot install tool. So I've gone ahead and I've measured the guide in the cylinder head and then picked the appropriate size of pilot. So that pilot is going to sit into the guide and it sits in on a taper. So we use the install tool and push against the taper to give us a nice solid connection between the pilot and the guide that's in the cylinder head. Now I've gone ahead prior to this instructional video and measured the guides to make sure that the guides are within specification for reuse, and they all are within specification for reuse. So there are some that have a little bit more wear than others, and that's still permissible. All I've had to do is gone ahead and use different guides for different holes based upon wear. So this one here in particular, we have this in the pilot into the guide now, and then we can install various tools for doing inspection. So this particular intake valve is a 30-degree valve face angle and 30-degree valve face seat. So we want to match these, and you can see that this one has already been machined. This was from another instructional video, and I've gone ahead and I've resurfaced all the intake valves and all the exhaust valves. They all fall within specs for having the correct margin width, and then I've got a very wide face here, and I want to make sure that I'm sitting in the correct position based on the recommendations from the manufacturer. The other thing I want to attain is the actual seat width contact, and the manufacturer gives us a guideline to go by for a reuse or new reconditioned specification. So taking a look at the cutters, this cutter in particular is sized for this hole, and you can see the sizing is quite a bit different between the intake and the exhaust valve. This particular engine uses a 30-30 wiping seat for the intake and a 45-45 wiping seat for the exhaust. The 30 allows the intake to open quicker, so there's less restriction for airflow coming in, and the 45 is a self-cleaning angle and promotes rotation when the valve opens off of its seat. So looking at the cutter itself, we have carbide bits on the cutter, and then we have a tool that we can go in and we can adjust these carbide bits to meet the cutting angle and the overall size that we're looking at for this particular repair. So taking a look at some of the information on the cutter, is it tells us right here that these top angles are 30 degrees and the bottom angles are 45 degrees. Because I have a 30-degree angle seat, I'm going to use the tool in this direction. Both ends of the tool have a bolster drive, and the bolster drive is just basically a square drive that allows me to drive the tool from either side depending upon what I'd like to cut. So next thing we have to do is take a look at exactly how wide these cutting heads are on here so that I'm not coming into the head boss or going too far down onto the seat itself. Because if I'm too far down, I'm going to cut on the wrong angle. And if I'm too far up, I'm going to cut into the head boss itself. And neither one do I want to do. So taking a look at this using our 30-degree cutter, and I just want to look at the position of the cutting heads in relationship to the actual seat. And following all the way around, and I'm just going to have a quick feel in reverse direction that I'm actually making connection between the cutter and the seat. And it looks pretty good at this point. So next thing I'm going to do is I'm going to go in and I'm actually going to resurface that condition so I can establish what my seat, my valve face to seat angle is and the amount of contact width I actually have. So two ways that this can be driven, and I'm going to show you both. One is with the hand tool. It gives the technician a lot more feel, and if only a small amount of material needs to be cut, it's easier to cut with the hand tool as opposed to using a motor drive arbor. And I'll show you that one momentarily. So I'm just going to go in here and I'm going to have a feel and a cut a couple times around. And I'm just going to back the tool up a bit to remove any of the cuttings from the face because I don't want it to actually burr the face. So I'm going to take a look in here and I can see that I've actually started to make the cut down onto the valve face itself. So I need to cut this one quite a bit so that I can actually bring it down far enough to establish my new angle. So the next thing I'm going to do is I'm going to bring in the arbor, the electric arbor, and I'm going to position it over the head. Now, the tool allows me to move over and do this one, to do this one, to do this one, and to do this one without much movement. So there's a lot of movement available on the tool. We also have the availability of pushing down on the tool, leaning either way to promote cutting if we have an unconcentric angle. So if the angles are not exact, we can lean or push depending on where we need to do the cut. So we'll just turn this motor head on, and without pushing down on it, we don't want to start doing any cutting. And this is just freewheeling right now with the weight of the tool. So what I want to do is I want to press down until I hear a little bit of load on the motor and I can physically see material being removed. So I'm going to let that cut just a little bit. I can feel it cutting, and now I feel there's less cutting effort. So I'm going to stop the tool and I'm going to pull it apart and I'm going to have a quick look to see what I did. So on the tool itself, there's going to be all sorts of material left in the carbide bits, and we use this brush for cleaning out the flute relief of that carbide bit. That flute relief area allows material to fall into the grooves without distorting the cutting surface. So the tool's fine, and then I'm just going to go in with my brush and just clean this up a little bit and have a look at what I did. Actually, pause. Do you want to zoom? We'll zoom in there.
How far in?
Oh, just right onto the edge here. Okay.
Okay, yeah, I got it.
So you can see after removing the tool and removing some of the debris from the cutting process, I've gone in and re-established a nice face on this valve seat. And that's what I want to do. And I'm feeling it around here, and there's no burrs on it. I don't see any burrs. It's a very shiny seat. A lot of the times these seats are either stellite, cast and stellite coated, or some of them are actually chromium molybdenum, so a chromoly coating with a molybdenum coating also that's part of the process of manufacturing. So that gives us the ability to maintain consistent seat angles and widths based on the operation of this particular cylinder head. So I see that I have a very nice cut here now. So the next thing I want to do is take my pilot removing tool, remove the pilot, and then I'm going to take the next selected valve, and in this particular case, because I've gone in and re-established the valve face cutting and the tip dressing on every single valve, I'm selecting valves for new cut seats now. So all I want to do is I want to take a black marker and I'm going to color this seat. I use the black marker because the black marker tends to rub off very easily and gives us a really nice picture of where our seat contact width is based on specification. Now, we don't want to be too close to the edge of the valve, and we don't want to run off the fillet area of the valve. So we'll drop this into the hole, and then I'm going to turn it a few times, round and round, to see if I can actually establish a pattern in here. Here's our pattern. You can see that it's got a very wide width to the area that I have cut. We still have a small amount of room back here, and it's just barely off of the edge. So we don't want to run off the edge. And you can see there's still some black marker evident there. We don't want to run off the edge, but we want to be slightly back from the edge. So what I need to do is I need to bring that down or from the top to actually reposition the overall valve contact pattern where it starts. Then I need to fall within specifications for the overall width without running off the back end or off the front end. So in this one in particular, what I need to do now is I need to go in and do what's called a topping angle. Topping angles run anywhere from 15 degrees to 31 degrees. And then we have our seat angle, which is in some manufactured engine designs. We run 30 degrees on the intake, 45 degrees on the exhaust. Some may just be 45 intake, 45 exhaust. And then we also have interference angles where we may have a 30 degree intake and a 31 degree face angle on the valve, or vice versa. Same with the exhaust, 46 on the face, 45 on the face of the valve seat, or vice versa, where we have 46 and then 45 on either or. So what I need to do now is I need to bring this down from the top. Pause. Okay, so to continue, I've gone ahead and I've readjusted these cutting heads to actually come in and make contact now at the top portion of the valve seat itself, because I want to remove material from the top, and we'll refer to the diagram for explanation of where we're actually removing the material and understanding how we're going about removing the material. So in this particular one, I've gone ahead now and I've set up my tool. I'm just going to drive it by hand to check my cut, and I'm cutting very nicely there. And I'm starting to remove material off the top. So what I'm going to do is I'm going to come in, I'm going to use the drive motor arbor here just to be able to pick up the speed of the process. So again, putting the drive in, allowing it to drive on its own on the tool. There's no pressure there. And then I can use these thumb screws now to actually press down, and I'm watching the pattern developing below me on the cutting face. And I can see I'm a little bit weak on this side, so I'm just going to turn the tool and lean slightly here, and I see my pattern becoming wider down on the top of the valve, on the valve seat itself. So, looks pretty good. And remove the arbor, get it out of the way, and then we'll take the tool off, remove any of the debris from the carbide bits, and then have a look at what's going on. So I'm going to take this out, and then I'm going to take my valve again. Now remember, looking at the valve, I had a very, very faint slight line just off the end of the valve by the margin. So I want it to come down further this way. So when we look at it in respect to the position, I need it to come down from the top of the valve contact pattern. So I'll clean the valve off, reinstall some black marker. Now, some technicians may use a lapping compound to actually determine the correct contact pattern. That would be for establishing where it is, not the finish pattern, because finish should be done through the machining process. So we can take this and we can drop it back into the hole, and we're going to turn it a few times and lift the valve back out. And then I'm seeing that the black line is becoming more evident on here, which means I'm coming down from the top. So what I need to do now is go back in. I'm just going to check once I put my pilot back in. The angle that these are on and the position. And it looks pretty good. So I'm going to go back ahead with the drill arbor, and I want to bring that pattern down considerably this time. So I'm going to put a little bit more pressure on it and allow a little more cutting to happen. I know I'm cutting because I can see the material coming off of the top of the valve seat itself. And then I release the pattern, just the pressure on it, just to allow the cutter to do its job momentarily. And I can see again, I'm actually cutting down further now. So again, removing the material from the tool itself. So I'm ready for the next cut. Removing the pilot. And then recoloring the valve again. Now, some technicians use pencil here, some use chalk. I think the black marker works the best because you can see the pattern it's removed and it doesn't leave any bad cleanup. Prussian blue gets used sometimes too. I would avoid using Prussian blue because of the dye and the paste that it's made up of actually travels fairly far on everything that you're working with. So again, the pattern's becoming wider down here at the valve face itself, so just off of the margin. And I want to continue with that until I actually bring the pattern back considerably. Okay, so continuing on, I've got the arbor set back up, or the pilot set back up in here, and then I go back in and do a little bit more of the topping angle to actually remove some more material. A little more aggressive with this time around, simply because I want to remove quite a bit of material to get me down to where I'd like to be positioned. Now, one thing I'm going to do is take my 45-degree cutter, and I'm just going to turn my 45 around on this by hand. Because I have two angles that I've cut on here now, and I just want to make sure that I have a nice contact. And again, I'm going to go backwards momentarily on the cutter to take any burrs out of the way. Taking the pilot out, and again going back in to recheck the contact pattern. Some machine shops actually have cutting bits now that will do a topping angle, a face angle, and a throat angle all in one cut to give the precise width contact. So they set the tool up, they run the cutter through it, or grinder, and then that actually establishes all of the correct width and the position of where the valve and face actually meet. The valve and the seat face meet. So again, checking the pattern, and again my black line is starting to show a little bit more here. So I would continue on with this process until I get it into the right position, and then what I want to do is I want to make sure that I have the overall right width on the face itself. So I'm going to go back one more time. I'm liking where that pattern is now. I'm going to go back one more time, and I'm just going to run around it with my face angle, which is my 30. I'm just going to do this one by hand because I only want to remove a very small amount of material. And then, once again, check my pattern. And again, I've got a really wide pattern now towards the back, but it's down from the face, and that's where I want to be. So just kind of shifting gears over here to a different valve. The other valve we were looking at, the intake valve, it's going to take a lot of time to actually do the process over and over again until I actually get to be exactly where I'd like to be as far as the width and where it is on the valve face. So this one here in particular shows a really good pattern. Again, this is our 45-degree valve face angle, and we have supporting width here based on manufacturer spec that we have enough margin left. And then I'm just going to go ahead and I'm going to color this valve face again, and then I want to take a look at it when I check it in its respected position. So I'm going to go around a couple times. If you're going half a turn, that would tell you if you have concentricity to the seat, and we'll look at the concentricity gauge here in just a moment. So taking a look at this one that I've spent quite a bit of time on, I have a really nice pattern here. It's nice and wide. It's up from the margin. There's lots of black marker showing. It's not running off the back side, and we have the correct width based on manufacturer spec for that wiping seat angle. Okay, continuing on, I've gone back to this hole in particular, and I've remarked my valve, and I'm going to put it back into the hole, and I want to check what the pattern looks like now to support whether I need to do more work or not. So you can see here that I have a really nice contact pattern. It's back from the margin, looks to be about a 30-second back from the margin. Then I have my overall seat width, and then I have the remainder of the pattern here that is not being contacted. We want to have the right amount of width, roughly into the middle or just slightly down from the valve face itself, or back from the margin, pardon me. Okay, so when we continually cut, if we were to cut more face, we would actually widen this pattern. If we were to throat it from the bottom, we would actually bring the pattern up from the bottom. If we were to top it, we're going to bring it down from the top to change the position. So we can take a look at that on the diagram. So we're going to continue on every single one of these until they're all in the right position. We all have the right seat width and the correct contact pattern. Then the head can be reassembled from the top side. And so next thing I want to do is I'm going to take some of this lapping compound. It's actually for lapping injector faces and seats. And I'm just going to put some of this paste onto the valve face. Remove any excess, make a nice smooth pattern on here. And what I'm looking for is the pattern that's going to be established just like it was with the black marker. Now, I'm using this very fine paste compound. It's about a 10,000 grit. Typically, valve lapping compounds are somewhere in the range of 80 to 120, maybe even 220, depending on what you purchase. The reason we don't use that to seat valves in is because of the grit compound actually impregnates into the face of the stellite and then can cause premature wear. So it's very hard to get that clean, and a lot of the times the cleaning that is done by technician is not 100%, so there's always going to be a residual amount left over. So this stuff here is very, very fine. Again, it's not that it's any better for the engine being finer, it's just we still have to take the time to clean it correctly. So I'm just going to put this back into its position again, and I'm going to turn her around a few times so I can actually see my contact pattern. Need to press a little harder. And the pattern is showing up but very faint, and it's in between my fingernails. So it's just back from the top and just ending right about here. So there's the width of the pattern. Again, down from the margin, back from the fillet, and pretty well covering the entire valve face. So we got lots of seat width. It falls within specification, and then we just continuing on. Now, if the specification is not wide enough, then we have to go back in and face angle it to support the new corrected width. Pause. So we've taken a look at the concepts of positioning the valve in the head in relationship to the overall width of the contact pattern. So one, we need to understand what we're doing when we're doing that. And I had made reference in the actual practical application to what we're looking at now. So if we take a look at the valve seat itself, the valve seat would look like this in the head. Okay? So this here is our face angle. And in this particular head, we were using a 45-degree face angle. So if I draw my valve in respect to the position, so here's my valve margin, okay? And then when we take a look at this, if this was to sit together, we would end up with a pattern that would probably be from here to about here, if we look at it in respect to where it would sit and make contact. So we have a really wide pattern, and it's too large. It's just down from the margin, which is okay, but it's too far down into the fillet area. And we call this the fillet area, where the head is actually bonded to the stem of the valve. So there's a couple angles we need to take a look at here. One would be the topping angle. And the topping angle, like I said in the training video, would be anywhere from 15 degrees to 30, in some cases 31 degrees. Depending on the cutter, depending on the manufacturer. Most times it's somewhere in the range of 15 to 31 degrees. So down here we can have our face angle, which is 45. If it is an interference, it may be 44 or 46 degrees. So the next angle we take a look at is going to be our throating angle. So the throating angle is going to be anywhere from 60 to 70 degrees. So that's down in this area here, the throat of the valve seat into the chamber. Now we're looking at this laying flat down, just like we resurfaced the head that we were looking at in the video. Normally everything's upside down in operation. So if our pattern is too wide here, we need to actually decrease the size of the pattern. So what we would do is we would take a topping tool, which we did do in the video, and we're going to start cutting material out of here. So as I continue to cut, I remove more material. So just like I did with the tools, is I remove some material here. Now you could see, in respect to where this valve would sit, the pattern would be somewhere here. Okay? Then if the pattern is too wide, too big, continually too big, then what I need to do is come down and remove material from the throat area. So what I'm going to do is I'm going to take my throating angle cutter, which is probably somewhere in a 60 degree, and I'm going to start to cut here. When I cut here now, I'm removing more material. Now we end up with the seat contact pattern right about here and right about here. So now our new established pattern falls within specification. Now, if the pattern you have gone in and you have topped it to bring it down from the top to get us a new position, and to bring it up from the bottom, throating it to get us into a new position, and I fall within spec, it's okay to run. If it's too small, then I need to make the pattern larger. So what I would do is I'd go back in with the face angle and now cut a new face. And as I cut the face, you can see that now my pattern is going to be larger again. So now the pattern comes in somewhere around here and comes in somewhere around here, now falling within the spec. Okay? So one, I'm in the right position down from the top. I'm in a good position up from the fillet. And our overall width is falling within manufacturer specifications. Now, depending on the spec, it can be anywhere from about 60 thousandths of an inch to around, oh, in some cases, 125 thou. Okay? So we can continually do this until the pattern is correct. Now, if we overtop it, we bring it down way too far, the only way to correct it is come back with the face angle. Now the problem is if we continually do too much of it back and forth, we cause the valve to sink into the head. And we don't want the valve to sink into the head. Different manufacturers ask for different specs for the position of the valve. Some manufacturers may say that here, this is the valve protrusion. Okay, so the valve has a specification for protrusion. Now, depending also on the manufacturer, it may actually sit slightly below the surface of the head itself. So if it's slightly below, then we actually have a recession. Okay, we have a recession. Now, the other thing that manufacturers look at is not necessarily the protrusion or the recession, but actually how far the valve sits down in, which is in respect to the stem installed height. So now we have what's called stem installed height. So, different manufacturers ask for different things. International, for example, looks at a recession value of how far it sits in. They don't have a specification in the manual for stem installed height. Other manufacturers, like CAT, only refer to stem installed height, no recession or no protrusion. Cummins looks at their N14 engines. They look at the protrusion of the valve, which is in respect to, again, the position of the stem installed height. So if the valve is sticking out too far, then obviously the stem installed height is going to be smaller, which allows more spring pressure. So all of these, the protrusion, the recession, and the stem installed height, all reflect on the amount of installed spring pressure, which is really important for holding the assembly together and preventing keeper flaying and valve toss and so on and so forth. Okay, so the next thing we need to do is we need to check for the concentricity of the valve seat to the actual guide. So I've put my pilot back in, and what we're looking at here is the angle of the valve face on the seat and the angle of the head. So if the head is slightly out of position because of the guide being worn, then we're not going to have an even seat all the way around. And what we want to do is concentricity explains that it's the difference between two parallel planes. This is one parallel plane, and the angle, the 90 degrees to this plane, has to equal the plane that we're looking at for the angle of the seat. So if they're too far out, then we see what's called an unconcentric angle, and then we have too much of a variation in the specification. So I've got my pilot installed, the seat is clean and cut, and now I'm just going to check my work. So we take this gauge here, which is our concentricity gauge, and we have a little small anvil on here that actually needs to ride around the surface of the valve face that I have cut. So I'm just going to bring this tool in, and I want to position it so that I have at least 50 thou, a preload on the tool, so I have a variation of values based on position. So now I'm just going to run this right against the seat surface with the anvil face, looking at the tool, and I've got about 75 thou, a preload on it, and I can dial my gauge now to 0. Okay, so you can see here that the gauge is preloaded, and my anvil is actually touching right onto the valve face itself. And you can see